So when I look at this first one, I like when I have expressions in factored form. I think they're a little bit easier. So this first term is x squared times x, that's x to the fourth. So since it's x to the fourth, I know I'm going to have 4 x values. X equals something, x equals something, x equals something, x equals something, 4 times. So when it's factored, it's easy. You set each factor equal to 0 and solve. So I can set x squared, anything attached to x squared equal to 0, x plus 2 equal to 0, x minus 4 equal to 0, and solve. So down here, I did that. I set x plus 2, x minus 4, and x squared equals to 0. So we get x is 4, x is negative 2, and some of you would just say x is 0. Remember, you need to count it twice, because when you take the square root, you technically have plus or minus, and it's a repeated value. So here we have 1, 2, 3, 4. So the degree is 4, so that makes sense. Now we already have the factors, right? The hard work's done. We have all these parentheses sets, and we can just write the x by itself 2 times. So now that we have the x-intercepts, we just write 0, 0, negative 2, 0, 4, 0. We could write 0, 0 again, but you don't need to. Y-intercept, if you plug 0 in for x, right, in all of the x spots, and simplify, you end up getting y is 0. So the point 0, 0 is y-intercept. As long as you draw a rough sketch, you're good. And just make sure you show the scale. So an x-intercept at 4, I have an x-intercept at negative 2, at 0, it's both an x-intercept and a y-intercept. And the sketch looks roughly like this image shown. Remember the notation, x arrow positive. That means as you look to the right, on our right, our graph is going up. So that's why we say f of x is positive infinity. Then over here this says as x approaches negative infinity, meaning as we look left, our arrow is going up. That's why we say positive infinity. So for this next one, what I always like to do is I like to put the equations in my calculator, and I like to see where it looks like it touches, where the graph touches on the x-axis, to see where the x-intercepts are. But they actually tell us that one of the x-intercepts is 2, 0. You need to recognize, though, that that means x is 2. That means it's touching the x-axis at 2. That means that the factor, if we move the 2 by the x, is x minus 2. So you need to understand that all of these are linked. When you're given a factor or an intercept, you use that in synthetic division to find the rest of the stuff you want. So you always put the x-intercept on the outside. So x-intercept 2. Then we do synthetic division, right? So number in front of x cubed is 1, in front of x squared is a negative 5, in front of x is negative 4, number constant 20. Next we add inside, multiply outside. So we do 1, right? 1 and nothing gets us 1. Outside we do 1 times 2 gets us 2. 2 and negative 5 gets us negative 3. Negative 3 times 2 gets us negative 6. Negative 6 and negative 4 gets us negative 10. Negative 10 times 2 gets us negative 20. Negative 20 and 20 gets us 0. Remember, if they tell us that they're giving us a factor, or if they give us an x-intercept, there should not be a remainder. Okay? If there is, you did something wrong. Now this makes our life a lot easier because we drop a degree. So if we start at degree 3, we're left with 1x squared minus 3x minus 10. So if what you're left with is something that you can factor, go for it. So ask yourself, is there a combination that multiplies to negative 10 that adds to negative 3? Yeah, 2 and negative 5. So therefore you can factor x plus 2 times x minus 5. And then to find your x-intercepts that remain, you set each of these equal to 0 and solve. And when you solve, you get -2 and you get 5. So the original that they gave us was 2, and the other two were -2 and 5. Since we needed 3 x values because the degree was 3, we have all 3. As shown below, we found all of our x-intercepts. This one was given, and then we did synthetic division and factored to find the remaining 2. And these guys are their factors. Right? Your factors are when you move the number back beside the x. And then x-intercepts, right? 2, 0, so the x value is 2, y is 0. -2, 0, 5, 0. To find the y-intercept, we put 0 in for x, as seen below. And when you simplify, you're left with 20. So the ordered pair is 0, 20. You can scale however you'd like. I scaled along the x-axis by 1 increments. That's why I did an intercept at 2, x5, x -2. But because my y-intercept was 20, I chose to scale the y-axis by 5s. So that's why my dot's there. And then I just did my rough sketch. Again, for in behavior, this means look on the right. And on the right, since our graph is going up, it's pos infinity. This means look on the left. And on our left, our graph is going down. That's why we say -infinity.